Two jets, one mid-air collision, both aircraft destroyed, 4 crew members falling through open sky above an Idaho air show with thousands of people watching from the ground. Every single one of them landed safely. The US Navy lost 2 EA-18G Growlers in a single moment. Aircraft that cost roughly $67 million each, gone in seconds. And the official response from Naval Air Forces was not a crisis statement. It was not an apology. It was a safety stand down and a quiet acknowledgement that the system worked exactly the way it was supposed to. 2 jets gone, 4 pilots alive. The Navy called that a win, and they were right. We don't cover the battle, we find the breaking point. If you want to understand the engineering that turned a mid-air collision into a survival story, subscribe, because what kept those 4 crew members alive was not luck. It was 50 years of testing, failure, and redesign that most people never think about until a moment exactly like this one. Type the word NACES in the comments if you have ever watched an ejection seat save a life and wanted to know how it actually works. To understand why 4 crew members survived something that should have killed all of them, you need to go back to a decision the US Navy made in the 1980s. The Navy Aircrew Common Ejection Seat, designated NACES and built by the British company Martin-Baker, entered service in 1991. The design goal was specific and demanding. The seat had to work across the entire flight envelope of carrier-based aircraft from 0 speed on a stationary flight deck to supersonic ejection at altitude. It had to protect a 103-pound female aviator and a 245-pound male pilot with the same level of force and the same probability of survival. That last requirement drove a decade of engineering problems. Early ejection seats were tuned to an average body weight. A lighter pilot ejecting at a standard charge got too much acceleration. Spinal compression injuries followed. A heavier pilot ejecting at the same charge got too little upward velocity. The seat cleared the aircraft, but the parachute did not have enough altitude to fully deploy. The solution was a propulsion system that senses the conditions of each ejection, airspeed, altitude, and a calculated estimate of the occupant's weight, and selects the appropriate charge and drogue deployment sequence in real time. That digital sequencer, which Martin-Baker describes as fully redundant, makes decisions in milliseconds that a pilot cannot make consciously in an emergency. It chooses the parachute deployment timing. It initiates the drogue. It activates the limb restraints that pull the arms and legs tight against the seat before the charge fires, reducing the chance of a broken arm from flailing against the canopy or the airframe. All of this happens before the pilot has processed what is occurring. Before we get to what happened at Mountain Home, understand what the EA-18G Growler is and why losing 2 of them in one moment carries weight beyond the price tag. The EA-18G is not a fighter jet with some electronics bolted on. It is the US Navy's primary airborne electronic warfare platform, the aircraft responsible for blinding enemy radar networks, jamming communication systems, and suppressing surface-to-air missiles before strike aircraft enter defended airspace. Every major naval air campaign the US has conducted in the past 15 years has depended on Growlers clearing the path. During Operation Epic Fury, Growlers flying from carrier strike groups jammed the seeker heads of incoming Iranian cruise missiles, causing them to lose target, lock, and miss without a single interceptor missile being fired. The cost per jammed missile was electricity. The cost of losing that jamming capability is measured in interceptors spent and ships hit. There are approximately 140 EA-18G Growlers in the US Navy inventory. That is not a large number for a platform that every strike package in every theater depends on. Losing 2 in a single accident does not cripple the fleet, but it matters. And the VAQ-129 Vikings that lost these 2 aircraft are not just a demonstration team. They are the Fleet Replacement Squadron, the organization responsible for training every new Growler crew in the Navy. When VAQ-129 stands down, the pipeline that produces qualified Growler crews slows. Now apply that engineering to what happened at Mountain Home Air Force Base on the afternoon of May 17th. The 2 Growlers were part of the VAQ-129 Vikings Growler demo team, performing at the Gunfighter Skies Air Show before a crowd of thousands. VAQ-129 is based at Naval Air Station Whidbey Island in Washington State and serves as the Fleet Replacement Squadron for EA-18G crews, meaning it trains every Growler pilot and electronic warfare officer who flies the aircraft in the US Navy. The demo team performs 2 jet displays, requiring close formation flying with precise spacing and coordinated timing. During the demonstration, one aircraft's nose struck the fuselage of the other from above and behind. Video footage captured from the crowd showed the 2 aircraft briefly entangled, nose up together, before departing controlled flight simultaneously. Both jets began losing altitude. The ejection sequences fired within seconds of each other. 4 parachutes opened above the falling aircraft. Both jets impacted open ground approximately 2 miles northwest of the base. The crowd watched 4 people descend safely while the aircraft burned below them. 1 crew member was treated for non-life-threatening injuries. 3 reported no injuries at all. The base went into immediate lockdown. The remainder of the airshow was canceled. An investigation was opened. Here is what that outcome required. Not courage, though courage was certainly present. Engineering. The Martin-Baker NACES seat is the escape system installed across every FA-18 Hornet, Super Hornet, and EA-18G Growler in the US Navy. Since entering service in 1991, more than 3,000 seats have been manufactured and delivered. The official survivability record for ejections conducted within the designed escape envelope is 100%. Every pilot and weapons officer who has ejected within the parameters the seat was designed for has survived. Over 100 lives saved since the seat entered service. The word within is doing critical work in that statistic. An ejection outside the envelope below a certain altitude, above a certain airspeed, or at an attitude the parachute cannot compensate for, can still be fatal. The seat cannot repeal physics. What it can do is extend the envelope of survivable ejection far beyond what previous technology allowed, and it can execute the escape sequence faster and more precisely than any human can under stress. The critical window is this. From the moment an ejection handle is pulled, the Martin-Baker NACES seat needs approximately half a second to fire the initiating cartridge, jettison the canopy, and begin the ballistic arc that lifts the occupant clear of the aircraft structure. That half second is not negotiable. The chemistry and physics of the escape sequence cannot be accelerated. What the seat can do is execute that sequence with precision regardless of the pilot's physical or mental state at the moment of ejection. This matters because ejection under stress is not the same as ejection in a test cell. A pilot in an uncontrolled aircraft has elevated adrenaline, narrowed attention, and degraded fine motor control. The handle requires a deliberate pull of roughly 40 pounds of force, substantial enough that accidental ejection is nearly impossible, but achievable by any pilot regardless of physical condition. The seat does not require the pilot to follow a procedure. It requires one action: pull. What happens after that pull is entirely automated. The fully redundant digital electronic sequencer initiates the canopy jettison, reads the airspeed and altitude sensors, calculates the appropriate drogue deployment, times the main parachute opening, and activates the limb restraint system that pulls the arms and legs tight against the seat structure before the ballistic charge fires. The occupant does not control any of this. The engineering controls it. The NACES back injury rate is documented at approximately 1% of ejections, compared to 20 to 40% in older ejection seat designs. That improvement came from decades of sled testing, cadaver studies, and the painful examination of ejection accidents, where the seat fired, but the pilot sustained debilitating spinal injuries. Engineers solved those problems by redesigning the charge profile to reduce peak acceleration forces and by adding the weight sensing system that tailors the propulsion to the specific occupant. Now apply that engineering to what the 4 VAQ-129 crew members experienced on May 17th. But the seat is only half of the survival equation. The other half is the training that put those 4 crew members in a position to pull the handle at the right moment, rather than trying to recover the aircraft past the point where recovery was possible. Naval aviation has a documented and painful history of accidents where crew members delayed ejection too long. The instinct to save the aircraft, to try one more correction, to pull one more time on a stick that is no longer responding, has killed pilots who had working ejection seats and sufficient altitude to use them. Consider the physics of what those 4 crew members faced. 2 aircraft departing controlled flight simultaneously, both losing altitude. Each crew aware that the other aircraft was somewhere in the same airspace, possibly on a converging trajectory. The instinct in that moment is to look for the other jet, to assess, to decide. Training overrides that instinct with a simpler instruction. When the aircraft is no longer flyable, pull the handle. Do not look for the other aircraft. Do not assess the situation further. Pull. The training that produces that response is deliberate, repeated, and deeply uncomfortable. Simulator sessions in which the correct answer is always the same. Pull the handle until the decision becomes automatic rather than deliberated. Physiological training that familiarizes aviators with the physical sensations of loss of control so that recognition time is reduced. Emergency procedure drills conducted until the sequence of actions takes less than 2 seconds from recognition to execution. The 4 crew members of those 2 growlers made that decision correctly, at the right moment, with enough altitude remaining for 4 parachutes to deploy. That is not luck. That is the product of a training system that has been continuously refined for 70 years, driven by the analysis of accidents in which the correct decision was made too late. Now stack all of it together. The aircraft were destroyed, $67 million each, $134 million in hardware falling as wreckage into an Idaho field. That loss is real and documented. The investigation will determine whether the cause was a sequencing error in the demonstration profile, a communication breakdown between the 2 crews, a mechanical issue that altered one aircraft's trajectory without warning, or a combination of factors that converged in a window too narrow for either crew to respond. That answer matters for safety, for demonstration doctrine, and for the future of the program. The Navy's safety stand-down covers 4 tactical aviation teams. That is a significant operational pause. It means that Growler training pipelines, demonstration schedules, and some operational activities are suspended pending the outcome of the investigation. The timing is not convenient. Operation Epic Fury is ongoing. The Navy's electronic warfare capability is in active demand. Pausing the organization that trains new Growler crews because 2 of its demonstration aircraft collided at an airshow is exactly the kind of decision that demonstrates institutional seriousness about safety and that costs something operationally to make. But the accounting that the Navy called a win is the one that starts with 4 people, 4 trained aviators who ejected successfully, whose seats performed within specification, whose parachutes deployed with margin, and who were walking and talking within minutes of watching their aircraft hit the ground. The Navy Aircrew Common Ejection Seat has a 100% survivability record within its designed envelope. The VAQ-129 demo team operated within that envelope. 4 crew members are alive because 2 generations of engineers at Martin-Baker spent decades solving problems that killed earlier aviators. Each problem solved in a test cell, in a sled run, or in the painful analysis of an accident that could not be undone, so that a future accident could be survived. The Navy issued a statement confirming all 4 aviators had safely ejected and were being evaluated by medical personnel. Navy Commander Amelia Umayam, spokesperson for US Pacific Fleet, confirmed that 1 crew member was being treated for non-life-threatening injuries, while the other 3 reported no injuries at all. The base went into lockdown. The air show ended. An investigation opened. The word safely in that statement is carrying the weight of 50 years of engineering decisions, test sled runs, and institutional memory about what it takes to keep a human being alive when the machine around them stops working. Martin-Baker has delivered more than 3,000 NACES seats since 1991. Over 100 lives saved, a 100% survivability record within the designed ejection envelope. Those 4 crew members on May 17th did not survive because they were lucky. They survived because decades of engineers solved every problem that would have killed them one problem at a time, one test at a time, long before they ever climbed into those jets. 2 jets lost, 4 lives saved. The hardware is always replaceable, the people are not. But here is the question the investigation has not answered yet. The Growler demo team performs close formation maneuvers that require split-second coordination between 2 crews. The same skills that make those demonstrations spectacular are the skills the Navy needs those aviators to practice for electronic warfare, suppression missions in contested airspace, where aircraft fly in close coordination under fire. The question is not whether to continue training those skills. The question is where the boundary sits between the demonstration that showcases capability and the demonstration that exceeds it. That boundary is what the investigation will draw, and where it lands will define how the Navy trains its most specialized crews for the next decade.